welcome back to Josh Does Math. In this video we're going to be solving a limit. So we're looking at the limit as x goes to 4 of x minus 4 all over x minus the root of x minus 2. So let's just try to solve this limit with direct substitution and see what we get. So we plug in 4, we get 4 minus 4 all over 4 minus 2 minus 2. So we get 0 over 0. And that's an indeterminate form. So we need to manipulate this in some way to get away from 0 over 0. And you might be kind of stumped looking at this because nothing immediately jumps out. Except for you can see in the denominator here, we have the root of x squared minus the root of x minus 2. So you can look at this x as the root of x squared. So that gives you a quadratic in the denominator in terms of the root of x. And you know you can factor a quadratic into two factors. So let's try to do that here. So we're going to write the limit as x goes to 4 of x minus 4 all over. So I'm writing this as the root of x squared minus the root of x minus 2. So now let's say I gave you something like this, y squared minus y minus 2. And I said, how would you factor this? Well, you'd say y minus 2 times y plus 1. Because whenever you do FOIL on this, you get back to your answer up here. Okay, well let's just say that y is equal to the root of x. Okay, well that just means that for this step down here, you'd plug in the root of x for both of your y's. So this is the exact same thing that's going on in the denominator here. So we can factor that in the denominator the exact same way as we factored it in terms of some variable y up here. So except instead of y, you're going to put in the root of x. So root of x minus 2 times root of x plus 1. And then we have our numerator up here. So x minus 4. Now let's try direct substitution again. Maybe we change it up a little. Well, you get 0 over 2 minus 2, which is 0. Doesn't really matter what this is. 0. So no, we didn't do enough. So what else can we do? Well, we have roots of x on the bottom. Maybe we can get this in terms of the root of x. And yeah, you could write this as the root of x squared. And now this becomes a difference of squares up here. So a difference of squares can be written as x root of x plus 2 times root of x minus 2. That's how you can factor a difference of squares, because whenever you FOIL that, you get back to this. That's all over the root of x minus 2 times the root of x plus 1. And I'm going to write the limit notation here because we're still taking a limit at this point. Okay, so this is what we have now. And as you can see, we have a factor of the root of x minus 2 on the top and bottom. So those can cancel. So we're left with the limit as x goes to 4 of the root of x plus 2 over the root of x plus 1. So let's just plug in let's just plug in 4 right now for every x, and we should get not 0 over 0. So we get 4 over 3. And at this point, we can say, okay, that's the value of the limit. But what if the limit doesn't exist? In other words, what if the limit from the left side is not equal to the limit from the right side? Well, how can you check this? Well, we'll just take this step right here and write, since we already got all the heavy lifting out of the way with canceling that term, the numerator and denominator, we'll just start at this step here, and we're looking for the limit as x approaches 4 from the negative side, and the limit as x approaches 4 from the positive side. And we need them to both be equal to each other. Okay, so let's just plug them in since we already canceled out those two factors that were giving us 0 over 0. So we'll plug in 4 from the negative direction, and we end up getting 2 plus 2 over 2 plus 1. And for the other equation, we also get 2 plus 2 over 2 plus 1. And that's the same 4 over 3 that we got whenever we just solved it generally for as x approaches 4. So as you can see, whether you're approaching from the left side or the right side, you still approach the same value. So this limit exists. And you would say the value of this limit is 4 over 3. Thanks for watching.